a value of 3 and x had a value of 1. Well, now that x is 4, x is less than y is no longer true. So I can no longer guarantee that condition because I have changed one of the variables within the comparison. So that means I cannot keep it. What about the other one? What about y is different from z? Can I keep that condition? Can I still guarantee that y is different from z?
Yes.
Yeah, because did I change anything about y or z? Nope, not at all. So that means that I can keep the other one. Very good. So this is relatively easy. Okay, that's it. We start with a precondition. We look at the statement itself, find out what it does, and then we try to come up with the post condition. Was it hard?
What does that say pre?
It
says pre.
The first one is pre, the second one is post.
It cuts off the first digit or first thing of every line. Look.
Sorry?
Take a look. It cuts off the first part of every line, so you can't really read it. Your alignment's off.
Oh, the alignment.
Move your window.
Let's see. I've never done this before, but I can give it a try. Remote control cannot be that hard, right? Okay. Probably has to do with exposition.
Yeah.
We'll just go ahead and tweak it a little bit. I think it has to do with the screen is too big, so I have to change the zoom ratio, which is probably the one. Sure. Oh wait, zoom is actually here. Zoom is not in one of the menus. Turn off the menu. Where's the zoom? There we go. And the remote control will come back, as a very important concept. Close to the end of this semester, the remote control will become a very important concept analogy. So we'll deal with it again at that time. Okay, is that okay? Everything is good now? Okay. Okay, let's start with line 1. Remember, a lot of times, from line 1, on line 1, or the precondition of line 1 is, I don't know anything about these variables. Remember, we have those, type of situations quite a few times already. Like the algorithm to find the maximum of 2 variables, we say, oh, we don't know anything about x, y, or z. Or the one that finds, the maximum of 3 variables, we don't know anything about w, x, y, or z. Okay, so we'll start with that. And we'll just say that line 1 is x get the value of, doesn't matter, 10, okay? Okay, so how do I state that I don't know anything about any variables before line 1 executes? What is the simplest expression that is always true? No, we cannot use question mark. Question mark means we don't know what it is. We do know the expression that is always true because that expression consists of a constant. What constant do you think it is? How about that? Look at the expression, true. Okay? Is the expression true always true?
Yeah.
Does it say anything about any relationship between the variables? That's exactly what I want. Okay, is that making any sense? No? Okay, let me just repeat that. From time to time, there are occasions where we want to say that we don't know anything about any variables. We don't know the relationship between the variables. We don't know the values of the variables. We know nothing. But yet, the precondition has to be a condition that is always true by the time we get to that line of the program. Okay, so what is the expression that is always true, but it doesn't say anything about any variable? True. Okay? So that's why we have the precondition of line 1 being true when I don't want to say anything about any variables. And there's no assumption of any kind in this case before line 1 executes.
So why are we writing a pre-statement before line 1?
Because you have to state that. it is important to state, what do you know before that line executes.
But it's the first line of code, you don't know anything.
That is correct. But not all algorithms will start with completely unknown relationships amongst the variables. Some algorithms start with certain assumptions. It's just that with this one, we do not start with any assumptions.
Okay.
But we need a way to express that we don't know anything about any variables. Okay? Are we okay with the concept of using true as a precondition? Is that good? Okay. What about the post condition of line 1 here? No. No. Exactly. This one is just saying that x equals 10 after line 1 executes. Does it make sense? Because after all line 1 does is to change and update the value of x to be 10. So it is guaranteed that x equals to 10, but since we didn't know anything before, there's nothing else to say in this case. Is that okay? Okay. So these are the easy tests, easy cases. But I think you guys are getting the hang of the precondition versus the post condition. So we'll try something a little bit more interesting now. So we'll try, this is on line 315. Yep, it doesn't matter. We're just saying that we don't know what the other 314 lines are doing. And we'll say, in this case, x gets x plus 1. Now, this is a little bit different now, because if you look at the right-hand side of this assignment statement, it refers to the variable on the left-hand side. Okay? It is special in many ways. So we'll go ahead and say that we know certain things about this condition. We'll start with something that is a little bit easy. Okay? Let's just say that we know only one thing about x. We know that x has to be exactly 47 before line 315 executes. Don't ask me why. It is as simple as that. Now that we have 314 lines of code already executed, it just is. Can we know anything about the post condition?
Yes.
X equals 48. Well, not a big deal. However, this is not how I would write it. I would say x minus 1 equals 47, which is saying exactly the same thing. But that is counterintuitive. If I have an easier way of doing that, why do I want to use a more obscure way and say that x minus 1 equals 47 instead of just saying x equals 49? All your math professors will ask you to simplify, right? Not to obfuscate. Okay, this is making it even more confusing and more difficult to understand. Okay, so we don't quite understand why that is the case, but we'll move on to the next example. The next example will be line 71. Line 71 says, x gets x minus 1. And once again, the right-hand side refers to the left-hand side. And this time, the precondition is a little bit more tricky. This time, I will simplify that to, let's see. Let's try x is greater than y. Okay, very simple, but nonetheless, very different from the previous one. Now, why do you think this precondition is a lot more tricky to deal with than the one that we have on line 315?
We don't know what y is.
We don't know what y is, okay? Because this statement is saying right before line 71 executes, the only thing that is guaranteed is the variable x is greater than the variable y. That is all that you need. That is all that you know. Okay. What about the post condition? Can we say anything about the post condition, or do we have to revert back to the true to basically say, well, I guess since we changed x may or may not be greater than y at this point, maybe we should just give up and say that we don't know anything about anything anymore.
The x
Or
lost
can
a
we?
value. You said x lost a value. You put that because you know that for a fact.
Exactly. So we can actually say that x plus 1 should still be greater than y after line 71 executes. Yep.
Why did you do x plus 1?
Because
If you
the plus 1 is undoing that minus 1. Okay, think about it this way, okay? Think about it this way. Steve Jobs is more wealthy than Tech. Okay? Steve, did I say Jobs or Bill Gates? Jobs, okay. Steve Jobs spent $1. Do we still know anything about our relative wealth? Okay, well, since before he spent that $1, he was more wealthy than I am. So maybe if I just say that, take Steve Jobs' current wealth, add that $1 back that he spent, that amount would still be more than what I have. Is that making any sense? Now this is without actually knowing how much Jobs has and how much I have, but I can still maintain the relationship. Is that making any sense? The plus 1 is here to undo the minus 1. Yep.
With pre and post conditions, as you're going through, do these affect each other? So like 71, would this be affecting the pre for line 72?
No, it would not go back and affect line 72 unless you have a loop. Then we have something that's a lot more hairy.
Okay, so the post doesn't lead into the next line's pre.
It does. Oh, okay, I take it back. Yes, the post of one line naturally becomes the pre of the following line if they are a sequence. Now, if those two lines come from different types of statements, then it's a different story. We'll get to those parts later. But yes, you were absolutely correct. The post condition of one line becomes the precondition of the line following it, unless you have a branch or a loop. Then it's a different story. Yes?
So is the logic that by the time you get to the post of your algorithm, that post statement should say something logically true, and if it doesn't, you have a problem somewhere?
The post condition hopefully will always say that blah, 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 blah has to be true by the time we get to the end of the algorithm. The big question is that what the algorithm is supposed to do? That is the big question. Okay? There's always a statement saying, okay, by the time this algorithm is completed, this has to be true. The question is that what the program is supposed to do? Okay? Yes?
For this, wouldn't it be easier to say greater than or equal to because it's only one value? It's always going to be at least
greater than or equal to only works if x is an integer.
So, because we're not really using integers, we're just using as a...
Wait, I just want to make it more general. So this is the more general way of saying it. Yeah, there will be an example later on with loops where we have to know that it is an integer for the post condition to work. But this is not one of those cases yet. Do we have any questions at this point? Why we can actually undo the operation and say, well, we know that we took 1 away from x, but if you add it back, not changing the value of x, this is just saying the sum of x and 1, that has to be greater than y if x was greater than y to begin with. Is that making any sense? And we can do this derivation from the precondition to the post condition without knowing exactly what x is and what y is. We only have to know the relationship between x and y. One was greater than the other one, and we can derive the post condition without actually losing anything. Okay? Now this is a big step. This is a big step. The constant assignments, I'm pretty sure all of us get in no time, but this is a big step. So after this one big step, we have to introduce some additional terminology. Okay? So we have to first introduce the word of a function. How many people are familiar with the word function in math? Okay, most of you are. So for the people who are not familiar with the word function in mathematics, I'll just explain it very quickly. It's a lazy way to do things. Okay? Think about this equation here. Okay? Think about this expression, x times x plus 2 times x plus 1. Okay, which is a quadratic